Hi, I'm Dr. Shah. I was the National Lecture Competition winner in 1989 and I'm the Maths Master at Maths School. Now, ready for a new way of doing maths? Now, a radical equation is one where x is inside the square root. So this first example here wouldn't count as a radical equation because it's only got 4 inside the square root. There's no x inside the square root. So that's not a radical equation. This one here is a radical equation. X is quite clearly inside the square root. So that's one that would count as a radical equation. That again would be a radical equation. X is inside the square root. This one wouldn't be a radical equation. X isn't inside the square root, it's just a square root of 3. So that's not a radical equation. This is a radical equation. And this again is a radical equation. So let's have a go at solving a couple of them. And we'll start with this one. The trick with solving radical equations is to start off by getting the square root term on its own on one side. So if we're solving this equation, we don't have any problems because the square root term is on its own on one side already. So the first thing I'm going to do is to get rid of the square root. Opposite of square root is to square. So I'm going to square both sides. So the square will cancel out the square root. And on this side I'm just left with x plus 1. And on this side 3 squared is 9. And now all I need to do is minus 1 from both sides to solve my equation. So that's solved. Now when you're solving a radical equation, it's very important to check your answer works back in the original equation. Because the step that we've done here, squaring, introduces false solutions. Well, it's easy for you to eradicate any false solutions simply by putting them back in the original equation. So this 8, I'm going to put it back in the original equation. 8 plus 1 is 9. Square rooted is 3, which does equal 3. So now I know that this is checked. So I can put checked next to that. Okay, so we've done that one. Let's have a go at this one, slightly more complicated example. First thing, as before, is to get the square root term on its own on one side. So that means I need to get rid of this 6 here, and so I'm going to minus 6 from both sides. And on this side that gives me x minus 6, and on this side is the square root term on its own, the square root x on its own. Now I want to square both sides. The rule for squaring an equation is you must first put a bracket around each side, especially if there's a plus or minus sign and separate terms, then must put a bracket around it and then square it. So the square cancels out the square root on that side, so I get x here, and here I get x minus 6 squared. Now I go back to my standard rules for solving an equation, which is get rid of fractions. I don't have any fractions. Multiply out brackets. Well, to multiply out x minus 6 squared, I first write it as x minus 6 times x minus 6. And then I multiply out those using the 4 arrows that you know to use when you're multiplying out 2 sets of brackets. So that gives me x squared. That's that one. This one is minus 6x. This one is another minus 6x. And this is plus 36. And on the other side it's equal to x. I'll just rub that out. And then simplifying as I go along, that minus 6x and the other minus 6x add up to minus 12x. So I get x squared minus 12x plus 36 equals x. And now I want to collect all the terms to one side, so I'm going to minus this x. And so that gives me x squared minus 13x plus 36 is 0. So I have my quadratic equal to 0 now, and I want to try and factorize that quadratic. To get x squared, I'm going to put an x at the front of each of the brackets. And to get 36, well, I could do 6 times 6, or I could do 9 times 4. I'm going to try 9 times 4. But I know actually that because that sign is negative, I want a minus 9 times a minus 4. Minus 9 times minus 4 does still give me 36. Let's check that works. X squared minus 4x, minus another 9x, that is minus 13x, and then plus 36 equals 0. And then now we've got our quadratic equal to 0 and factorised, so that means either the first factor must be 0 or the second factor must be 0. For this factor to be 0, x would have to be 9, and for this factor to be 0, x would have to be 4. So these are my answers. Now remember, if we have a radical equation, we must check our answers back in the original equation, because the step that we did first, which was squaring, introduces false solutions. So I'm going to start with this x is 9, put it back into the equation. 9 equals 6 plus root 9. Well, root 9 is 3, 6 plus 3 does equal 9, so this one I have checked. And let's now try checking the other answer that I got, x is 4. So if x is 4, 4 equals 6 plus root 4. Well, root 4 is 2, 6 plus 2 is 8, that's not 4. So this answer is not a valid answer. So we're only left with one answer.